All right, good morning and welcome to the start of Chapter 3. Once again, I know we've already done Chapter 5. The reason they're out of order is that's the order the textbook goes in. Now, obviously, we aren't using textbooks this year with COVID and stuff, but Chapter 3 is what we are on now, so that's why the numbers are like what they are. Now, we're starting the new note packet. If you don't have it, remember you can get it outside door 20 or contact me if you need help getting it. The other option, go print it. It is in the Chapter 3 folder at the top. Okay, you can print it off. Now, if you don't have it, still watch this video, see what you can take away. Okay, now, scatter plots. These are some different examples of scatter plots. And this first one, as you can see, it's not perfect, but it's roughly like a line. Okay, so this one would be linear. Now, this second one, as you can see, there's a clear shape. It's not just random like the last one. However, it is not a line. It changes. This one is what we're going to call nonlinear. Okay, what we mean by that is there's some sort of clear pattern, but it's not a line. Now, nonlinear will not always look like this, like the parabola. Okay, sometimes it'll look different, but the key is it can't be a line. And then our final one, this would be neither of those, okay, or neither, depending on how you say that, but neither of them. It's just kind of random. So I'll give you guys a minute. Take a look at these four and try to classify those as either linear, nonlinear, or neither. So if it's just totally random, then we put nonlinear. If it's totally random, we put neither. If it appears to have a pattern but it's not a line, we'd put nonlinear. And if it's a line or very close to a line, we put linear. So this first one here is going to be linear. The second one is kind of just random, so that one is neither. Okay, our third one, once again, linear. And then your final one kind of looks like an exponential maybe. So it's got a pattern, but it's not linear, so we're going to call that nonlinear. All right, so here we are. We're going to create the scatter plot and then classify it. So we've got our x term and our y term. And then we're going to choose one of those three options, linear, nonlinear, or neither. So all we got to do, -6, that's our first point. So 1, 2, 3. We count 6 to the left, 6 down, and that's my first one. Next one, -5, -3. Okay, -1, -2, 0, 2, 3, 3, and finally 5, 6. Now here's the deal. It's not a perfect line, but hopefully you can see it is in the same general direction. As one increases, so does the other. So that is going to be what we call linear. All right. Let's go ahead and flip it over, and we can start by classifying or by creating our scatter plot. Okay, so this can be a bit tedious. If it helps you, maybe put little marks. So each of these is 5, 10, 15, 20. That can kind of help you maybe do it a little quicker when you glance at it. So once again, we want to start by just plotting all of these points. So the first point, 14, 6. Over 14, up 6. Even though it's not labeled, we always know our x is horizontal or our y is vertical. Okay, the next one, 4, 1. I'm just checking it off as I go in case I lose my place. 7, 1. That way I know I already put it there. 14, 8. 8, 2. 19, 22. 12, 5. 10, 3. And then 6, 1. All right. So then 6, 1. 17, 11. 15, 15. 1, 1. And 18, 18. All right, now this one maybe is a little hard to classify because some of you might think, let's see if I can find, I don't think I have a line tool over here. Oh, maybe there it is. I understand why you might think that is close to a line, but if we think about it here, it is coming in, it starts really slow and then it slowly starts to increase. This is almost more exponential in shape. Okay, so instead of being linear, we have to call this nonlinear. All right. So the next thing I want us to talk about here, if we look here, there's a couple different correlations. Now this first one, as time increases, so do the calories burned. Okay, so that is going to be what we call positive correlation. As one goes up, the other one goes up. So if you want, you can put down here as time increases, so do calories burned. All right, now our next one. If we look here, it's almost more just random. It's inconsistent. As time goes up, as number of siblings goes up, as the X goes up, the number of pets is random. Sometimes it's higher, sometimes it's lower. So this is what we call none. There's no correlation, okay? And you can think of that, it's just inconsistent. Okay, and then our final one here, hopefully you can guess, as weight goes up, the number of reps they can do goes down. This is known as a negative correlation, okay? As one increases, the other decreases. As X increases, the Y decreases. So, as weight increases, the number of reps decreases. All right, now I know we're used to only doing 1 page a day. Today we're actually going through 2, just because with the graphs it took a little bit more space. Go ahead and flip it to the next page, 3.1 continued. And we're going to start, we just need to graph these. And then we'll kind of analyze it once again. So once again, go over 1, 2, 3, 4, 5. I'm just going to put a mark. So 5, 10, 15. Okay. Likewise, 5, 10, 15. Okay, so 12, 5. 4, 6. 8, 7. 6, 3. 15, 6. 7, 12. Let's see, next is 8, 2. And finally 3, 8. Okay, so linear, nonlinear, or neither. And this is going to be neither. It's just kind of random. And here's the deal. I didn't ask for this, but anytime it's neither, if we look, is there a positive or negative correlation? There's actually no correlation because as one increases, the other one sometimes goes up, sometimes it just isn't consistent, okay? So it says create a scatter plot and corresponding table of values that is linear and has a negative correlation. Now, this one, there'd be a lot of correct answers. I'm not going to worry about the scatter plot or the table as much, but basically, it doesn't have to be a perfect line, but it would be something along the lines of this. Right? The general slope of a line looks negative, so that's a negative correlation, and it's basically a line. Okay. So the final one we're going to do together today. Okay. For this one, it says the average monthly temperatures in degrees for Indianapolis are given in the table. Okay, we want to create a scatter plot for this. So on the bottom, we're going to have month, and then on the side, we're going to have the temperature. Now let's start. We'll label this in months, and if we do this, I'm going to go every other, just so we have a little space. So let's see, January, February, March, April, May, June, July, August, September, October, November, and it looks like I need one more, December. All right, now we have to be careful on this next one because on the left side here, we don't have enough. We can't go by ones. In fact, we can't even go by twos because if we look here, the lowest point, the lowest average is in January at 28. Highest average is 76 in July. We need to go all the way to 76. So what I'm going to do is I'm going to make this little symbol here. And that allows us, because it normally starts at 0. If we put that symbol there, now we can jump up. That'll be at 20. Okay, so now I'm going to go 2 spaces and go by 5s is what I'll do. And this is just kind of up to you what fits. If you wanted, you could go 5, have each space be 5. We just want to kind of maximize our space, though. And we've got plenty of space to go by 5s. And that's 75, and then 80, which, as we know, gets us above our high of 76. So now, let me zoom out so we can see all the information we need. All right, so January is 28. So under January, come up here, it's going to be just over halfway between 25 and 30. Okay, February is 32. It doesn't need to be perfect, but approximately. Okay, March then is 42. April is 53. May is 62. June is 72. July is 76 here. August will be 75. September is 67. October is 55. November 44. And then finally December gives us 31. All right, now hopefully when you look at that, you can see it has a nonlinear relationship. It kind of looks like a quadratic, so we're going to call that nonlinear. And it doesn't say what's the correlation because anytime we have a nonlinear, oops, I misspelled linear, but anytime it's nonlinear, there can't be a correlation, okay? Correlation only works for linear. Okay? So that's our homework. Take a look at the It's Learning assignment. Please get that done, and hope you guys have a great day. Let me know if you have any questions.